Hello everyone, welcome back. In the previous video, we learned KCL and KVL, solved a simple circuit using those laws. Today we will learn two systematic techniques that are extensively used in circuit analysis, nodal analysis and mesh analysis. We will also briefly understand two important concepts, supernode and supermesh. These frequently appear in gate problems. Let's begin now. Let's quickly recall the two fundamental laws. KCL, which states that the algebraic sum of currents at a node is zero, or current entering equal to current leaving. Then we have KVL, which states that the algebraic sum of voltages around any closed loop is zero. Nodal analysis is based on KCL, mesh analysis is based on KVL. Let's first understand nodal analysis. Suppose a circuit contains several branches. Instead of writing KCL randomly, we first identify the important nodes. A node is simply a point where two or more elements are connected. In nodal analysis, our unknowns are the node voltages. Then we apply KCL at those nodes. So remember, nodal analysis is equal to finding node voltages using KCL. Now let's understand the rules of nodal analysis. In the very first step, we need to choose a reference node, that is a node with 0 volts. Next to that, we need to assign voltages to the remaining nodes. In this circuit diagram, the voltage we have assigned to this node is V1. Next, we need to express every resistor current using Ohm's law. Consider the current passing through the resistor R1. Considering this current direction and the voltages at the terminal of resistor R1, we have the voltage across the resistor R1 given by 10 minus V1. Based on Ohm's law, we have I given by V by R. And so, the current through the resistor R1 is given by 10 minus V1 by R1. Here R1 is nothing but 2 ohms. Next, if you consider the current through the resistor R2, since one terminal of the resistor R2 is grounded, we have the voltage across it given as V1 minus 0, that is nothing but V1 by R2. And next we have resistor R3. Voltage across it is again V1 because one of its terminal is grounded. Now let us apply KCL. If you consider the node V1, assuming clockwise current direction in both the meshes, current enters the node V1 through resistor R1 and exits through resistor R2 and R3. Therefore, we have 10 minus V1 by 2 equal to V1 by 4 plus V1 divided by 6. We obtain this particular equation based on the current directions we have assumed. And next, solving it, we obtain 6 into 10 minus V1 equal to 3V1 plus 2V1, which is nothing but 60 minus 6V1 equal to 5V1. So V1 equal to 60 by 11, which is nothing but 5.45 volts. As you can see here, even though the circuit has two meshes, only one KCL equation was required. What is a supernode? Sometimes a voltage source is connected directly between two non-reference nodes. In this situation, we cannot directly write the current through the voltage source because its current is unknown. Instead, we combine the two nodes into a single larger node. This is called a supernode. Then, instead of writing KCL at each individual node, we apply KCL to the entire supernode. In this particular case, we have two unknown node voltages VA and VB, and we have an independent source voltage of 10 volts. By applying KCL, we obtain VA by 5 plus VB by 10 equal to 0. Along with that, we write one additional equation using the voltage source VA minus VB equal to 10 volt. That's all a supernode is. It is simply two nodes treated as one because of the voltage source between them. Now let us understand mesh analysis. Instead of assigning voltages, we assign currents. A mesh is the smallest closed loop in a planar circuit. Here, our unknowns are the mesh currents. Then we apply KVL around each mesh. So remember, mesh analysis equal to finding mesh currents using KVL. Now let's understand the rules of mesh analysis. At first, we need to identify the meshes, assign mesh currents. Clockwise direction is commonly chosen, but there is no strict rule for that. You can choose any direction. If the resistor belongs to only one mesh, its current equals that mesh current. As you can deduce from the circuit diagram, the current passing through the resistor R1 is I1, current passing through the resistor R3 is I2. If a resistor is shared by two meshes, both mesh currents pass through it. If you notice the resistor R2, both the currents I1 and I2 flows through it. Now, current through the resistor R2 will be I1 minus I2 if you consider with respect to mesh 1, and will be I2 minus I1 if you consider with respect to mesh 2. Now let us apply KVL on this particular circuit. From mesh 1, we obtain 4 into I1 plus 2 into I1 minus I2 equal to 12, which is nothing but 6 I1 minus 2 I2 equal to 12. From mesh 2, we obtain 6 I2 plus 2 into I2 minus I1 equal to 0. That is nothing but minus 2 I1 plus 8 I2 equal to 0. Based on equation 2, we know minus 2 I1 plus 8 I2 equal to 0. So 2 I1 equal to 8 I2. So I1 equal to 4 into I2. And from the first equation, we know 6I1 minus 2I2 equal to 12. Substituting I1 in terms of I2, we have 6 into 4I2 minus 2I2 equal to 12. 24I2 minus 2I2 equal to 12. Solving this, we get I2 equal to 12 by 22, which is nothing but 6 by 11, or 0.545 amperes. At the same time, I1 is 4 into I2, which is 4 into 6 by 11, that is nothing but 24 by 11, or 2.182 amperes. Next, let us understand what is a supermesh. A current source is connected between two adjacent meshes. Since the voltage across the current source is unknown, we cannot directly apply KVL around those individual meshes. Instead, we combine the two meshes into one larger loop. This larger loop is called a supermesh. Now, we apply KVL around the outer boundary, avoiding the current source. Finally, we use the current source to write one additional equation, I2 minus I1 equal to 2. Whether it is I2 minus I1 or I1 minus I2 depends upon the direction of the current source. Because it is similar to the direction of I2, we have chosen I2 minus I1. That's all a supermesh is. So, when should you use nodal analysis and when should you use mesh analysis? A simple guideline is, if the circuit has fewer unknown node voltages, nodal analysis is usually faster. If the circuit has fewer meshes, mesh analysis is usually easier. With practice, you will quickly identify the better method. Thanks for watching, and I'll see you in the next video.